Hello group, this is part 2 of the presentation, how to write the electron configuration. So last time we discussed shells, subshells and orbitals. Now today let's focus on electron configuration writing. Before that, you should know there are two principles and one rule. First one is Aufbau principle. Aufbau principle, another name is building up principle. This is states that you need to fill the electron to the lowest possible subshell and then fill to the next highest energy and then next highest and so on. You have to fill the electrons from lowest energy to the highest energy orbitals. That is Aufbau principle. And the second one is Pauli exclusion principle. Pauli exclusion principle. Pauli exclusion principle states that in single atom there is no two electrons have same four quantum numbers. So in other words, if you draw electrons as arrows, you have to draw one up, the other one should be down in one orbital. If you draw one up, the other one is up within the same orbital, or down within the same orbital, they are not correct. They have same quantum numbers, at least one then. So you should draw one up and the one down arrow. That is Pauli exclusion principle. Third one is Hund's rule. Hund's rule is, if you have degenerate orbitals, example p orbitals, there are 3 p orbitals with equal energy, px, py, pc. Or if you consider d orbitals, there are 5 d orbitals with equal energy, d1 to d5. Or if you consider f orbitals, there are 7 f orbitals with equal energy. So if you have the orbitals like this, equal energy orbitals, you need to fill the electrons first one at a time. 1, 1, 1. And then if you have fourth electron, then go backwards to the first one and then start pairing. And if you have 3 electrons and if you draw like this, one pair and one single electron, that is not correct. First you need to draw single electrons until they have filled, and then after they halfway filled, and then start pairing. That is stated by Hund's rule. First they should be singly occupied before you pair the electrons. Right? The Aufbau principle is building up principle. Lowest energy to highest energy, you need to electron filled. Pauli exclusion principle, one electron spin up, one spin down. And Hund's rule is electron singly occupied to the all degenerate orbitals before they paired. So those are the 3 rules you should know before you writing the configuration. Now let's learn how you can write electron configuration. So I will generate a chart, the electron filling pattern. So this chart will include exam reference material I have uploaded to the canvas. So if you want, you can take a printout during your homework and exams. Okay, this is how you can make your own pattern. First, n is equal 1 level, only 1s, and then 2s, 3s, 4s, 5s, 6s, and then n is equal 1 level, only s orbital, but 2s, there are 2s and 2p subshells, and 3s, 3p, and then 3d, and then 4 level, 4p, 4d, and 4f, and then 5s, 5p, 5d, and 5f, and then 6p, 6d, 6f, and so on. Now you have to draw lines through 1s, and then 2s, and then 2p, 3s, and then 3p, 4s, and so on. Now you can see the electron filling pattern. First you need to fill the electron to the 1s, and then you have to fill the electron to the 2s, and then fill the electron to the 2p, and then 3s. Next one is 3p, 4s, 3p, 4s, and then go backwards. It is 3d, 4p, 5s, and then 4d, 5p, 6s, and so on. So this is how you can identify the electron filling pattern. This is according to the energy. The lowest energy in 1s and 2s, 2p, 3s, 3p, 4s, and so on. Now always s orbitals can hold maximum of 2 electrons, and p orbitals can hold maximum of 6 electrons. You can fill up to 6, and then d orbitals you can fill up to 10, and f you can fill up to 14. Right? Now you all know the pattern. So let's start writing configuration for first 10 elements in the periodic table. First element in the periodic table is hydrogen. Atomic number C is equal 1. So let's build our electron to the lowest possible level, 1s1. So 1 means the n is equal 1. This is principal energy level 1. S means the orbital name. 1, the superscript 1 means how many electrons here. Atomic number 1 means 1 electron you need to fill into lowest possible energy level. So 1s1 is the configuration for hydrogen. Helium, C is equal to. There are 2 electrons we need to fill. We can fill that electron into the same level, 1s2, because S can hold maximum 2 electrons. Third element is lithium. C is equal 3. So 1s2, our next energy is 2s, 2s1. And then beryllium, C is equal 4, 1s2, 2s2. N is equal 1s level, there are 2 electrons. N is equal 2s, there are 2 electrons. Boron, C is equal 5, 1s2, 2s2, 2p1. Right? And then carbon, C is equal 6, 1s2, 2s2, 2p2. And then nitrogen, oxygen, fluorine, neon. C is equal 7, 8 for oxygen, C is equal 9 for fluorine, and then C is equal 10 for neon. So let's fill the electrons, 1s2, s electrons maximum 2 in 1s level, and then 2s2, here 2p3, and then 1s2, 2s2, 2p4 for oxygen, two p6 for neon. S level maximum 2 and P level you can fill up to 6. Now N is equal 2 level now completely filled having 8 electrons. N is equal 1, 2 electrons. So maximum 10 electrons for the neon. Right? Now let's see if you have the next one, sodium. C is equal 11. See, you have to fill 11 electrons, that is 1s2, 2s2, 2p6. N is equal 1 level and N is equal 2 level. Both levels are completely filled now. So let's jump into next highest energy level, that is N is equal 3 level. So N is equal 3 levels, the lowest orbital is 3s1. So this is the configuration for sodium. If you write magnesium, then C is equal 12. Same configuration up to here, and then it becomes 3s2. And if you want to write aluminum, it is C is 13. Then same configuration up to 1s2, 2p6, and then 3s2, 3p1. Right? So these are the configuration, electron configuration for first 13 elements. So always try to follow this format, lowest possible energy level to the highest energy level. And then you can easily fill the electrons according to this energy increasing order pattern, right? Now let's move on to the second topic, noble gas shortcut, or we call noble gas notation. So the same configuration, how we can write according to noble gas shortcut. What is the meaning of noble gas shortcut? What are the noble gases first? Noble gases or the inert gases are the gases in the group 8A. Group 8A, helium, neon, argon, krypton, xenon and radon. These are the noble gases, group 8A. So if you consider any element, let's talk about the sodium, and its atomic number is 11. If you write the long configuration, 1s2, 2s2, 2p6, 3s1. Now you have to find what is the previous noble gas to the sodium. Previous noble gas to the sodium means sodium in period number 3, that is row number 3. Row number 1 hydrogen, row number 2 lithium, and then row number 3 is sodium. And row number 1 noble gas is helium, and then next noble gas is neon, and then in the sodium column the noble gas is argon. This is group 8A, group 1A. So what is the previous noble gas? What is the noble gas previously to the sodium is neon. So let's write the noble gas within the square brackets, neon. So how many electrons this neon represent? 10 electrons. So without writing first 10 electrons, 1s2, 2s2, 2p6, instead of this 10, we can write neon within the square brackets. It represents 10 electrons. And how many electrons remaining? 3s1. So this is we called noble gas shortcut configuration for sodium. Let's write another one, calcium. Calcium, the long version of the configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And for the calcium, atomic number is 20. Let's find out what is the previous noble gas to the calcium. So calcium in period number 4. In period number 3, the previous row, noble gas is argon. Let's write argon within the square bracket. So how many electrons represented by argon? 18 electrons. So without writing this first 18 in the configuration, you can write argon within the square bracket. And what is the remaining configuration? 4s2. So argon 4s2 is the electron configuration noble gas shortcut for calcium, right? So always you have to write find out the previous noble gas to the considered atom. So this is useful if you have electron configuration atomic number greater than 20. It is very long configuration. Some atoms you need the whole sheet of paper to write configurations. For that cases you can shorten the longer versions using this shortcut method, right? The important thing is practice. So practice, get hands-on experience how to write the configuration, how we can write the shortcut method before your exam. Okay, good luck everyone.